All right, so we downloaded this demo program from this presentation. You know, the previous link here gave us this link. So we downloaded it, and I have it here. So I'm just going to run it. And so it has a demonstration for some containers and some algorithms, and also some special facilities such as adapters for iterators, which we may get to or may not get to today. Also function objects, and by the way, these things are being taken to the next level with the latest C++ standard, but perhaps not the talk of today. Today, let's take a look at vector constructors. So here's some demo code, and so we have essentially a function that is a placeholder for some of this work. So let's basically we say that a vector provides a complete set of constructors, a destructor, and copy operations. So that's expected from a dynamic array of integers or array of some other objects. So here's creation of a vector. What I do here in those demonstrations, I just display the name of the object, but I also have this little marker for where the container ends. So right now the container, as it was created here, is created empty. It's empty because it has no elements. I just said I want to create an empty vector. So here's another vector, vector 2, which we created, named vector 2, but we said that we want to create it with 5 elements. Now the question is, what elements? Each of these elements is constructed by default element for a specified type. Interestingly, you can find out what is the default element value for integer. You can say integer x equals int and use a constructor syntax, right? So C++ standard allows you to use even primitive types with constructor-like syntax, and I can assure you that doing this will return 0. The default value for an integer is 0, so that's why when we executed this code, those 5 elements were populated by 0, because we didn't say anything. We just said we want a container with 5 elements. Well, sure, it instantly is created for you, and all 5 of them are populated with default value for an integer. Of course, if we were creating a vector of strings, then this would be populated with vector of strings, and the default value for a string, the default constructor for a string, will create an empty string, right? And a string of length 0, right? So no characters in it. So anyway, that works. So you can of course use new operator with vectors, just like this, right? So you can say, all right, create brand new vector dynamically. Okay, that's just like you can say new with primitive data types. You can do it with objects, and of course vectors and strings and other components of the standard library are user-defined types, and so you can apply new to them. And here I created just one dynamically, and I stored my pointer to this object created dynamically in a pointer, which is a pointer to a vector of integers, because that's the kind of object that I have created. If I say delete, right, this goes away, right? So it just wipes itself off. It's gone. All memory is returned back to the free store. So you can obviously allocate them dynamically. Here's something else. Vector 3, v3, is constructed with 3 elements using a call to rand, which returns a random number, and I'm going to take the remainder of this random integer, a remainder of the from the division by 100, and so this is some sort of a number within the range of, you know, from 0 to 99, obviously, right? So in my case, it was 58. So if I just shut down this program entirely, the way it works, it actually executes this code. it does execute this code. And so, but then for reasons of efficiency, what happens is that if I jump away from this example and go back to it and go back here, it sort of remembers the value. It just executes this code only once. But if I exit out of here entirely, right, and go right back and restart this program again, right, and go back to my constructor thing and go back to this line, see, this time the random number was picked 40. So it's no longer the same number. So this program actually executes the actual C++ code, and what happens is just that everything, all these components basically try to visualize themselves. So you create a vector, it visualizes itself like this. You create this guy, it visualizes itself like this. If you have this vector and then say delete, it goes away, but before it goes away, it also updates the string value and displays its internal structure, if you will. So here you go. So we were able to, by exiting the program and coming back, we were able to see that yes, it's really some dynamically generated random number that gets generated here. But the matter of fact is that apparently result of this was 40. So this particular constructor of my vector, and by the way, I have like a syntax error here displaying it. It needs to say int, right, because it's still vector of integers. This is a syntax error. Apologize for that. But this is similar to something like this. Here we said vector of particular size, but also provide the value for all elements to begin with. So right now, size is 100. So I'm saying create a vector of 100 integers initially populated with the value 40, right? So that's exactly what happened here, but we picked the random number, and the size of our vector here is 3 elements. Okay, so again, the chat here, our look is at vector constructors and some of the copy operations, which of course we know are also handled by vector constructors, because there's a copy constructor that essentially handles any copying from one object to another object. So here's just simple assignment. Vector 3 is going to be assigned to vector 1. Right? So typically with an array, you need to either use some system functions like memory copy, or go by element and copy individual elements. Here, if you need to quickly see, vector 1 and vector 3 are both vectors of integers, so they're basically the same type, but the content is different. So if I say assign, simply all of this gets transferred over here. So the content is assigned. Forms of assign, if you recall our discussion about strings, at some point we said that there's a whole bunch of assignment functions available with the string. Similarly, let's see, vector 1 assign 4 elements of 77. So look what happens here. The content is replaced by this one single statement with 4 numbers, 4 integers containing 77. Vector 2 right here, assign something from the beginning of vector 1 to the ending of vector 1. So this is the first kind of touch of iterators. We're going to talk about iterators in just in a few minutes, but this should be obviously very simple. Basically, the whole content of vector 1 is going to be assigned to vector 2. Now notice that vector 2 has 5 elements, vector 1 has 4 elements. So this, regardless to what the content is, the counter of actually it's the other way, right? I'm trying to assign vector no, I'm trying to give vector 2 the content of vector 1, right? So what happens is that it's just basically gets assigned everything from this vector. By the way, take a look at this animation again. You see those single lines? Those are the iterators. We'll talk about that. There's actually iterators are also objects, and when this animation takes place, they visualize themselves as lines because they're being used as pointers. So anyway, but there's a whole family of assignment functions. Interestingly, you can resize your container. And you can say, well, listen, I have something in vector 2, but I want now to make it, the length of vector should be 2. Right? So you click that, it just shrinks it. Right? If I said resize it to a size 20, previously this is what it was, right? It was like 777 4 times. Right? But if I said resize it to the size 20, and I think we have this demonstration later on, resize to bigger size and so forth. What happens is that if the size needs to increase, again, the missing elements, the brand new elements, are filled in with the default value. However, resize could take the default value. So if I say now resize to the size of 5 elements and fill them in with 18, so they get filled in. So you get this, you can see how powerful, simple, readable, maintainable this code is. Make no mistake, all of these numbers that you see are created by new and then handled by delete at some point. But you don't have to worry about it because vector is such a high-level dynamic container, and it's also guaranteeing to produce a highly efficient code.